Hello and welcome back to Introduction to Astronomy. In our previous segment, we did Newton's second law of motion. So what was his first law of motion? An object in motion tends to stay in motion unless a force acts on it. Okay, what was his second law of motion? Force equals ma. And now what we want to do is his third law of motion, which says for every action, there's an equal and opposite reaction. So what do I mean by that? Okay, that means that if I've got a wall over here, so here's my wall. See that wall? So if I push on the wall pushes back against me. Now if you push on the wall and the wall can't push back on you with the same amount of force, then you're going to go through that wall. Okay, you're standing on the floor. What does that mean? Your body is exerting a force on the floor equal to your weight. So what's the floor doing? The floor is pushing up against you with an equal and opposite force equal to your weight. So if you weigh 120 pounds, what's the floor doing? It's pushing up against you with a force of 120 pounds. Otherwise, you're going to be going through the floor. So this is very, very important because it allows you to be able to move. So let's just talk about walking. So whenever you take a step and you're going in that direction, think about what your foot does. Your foot is pushing down, but what else is it doing? Your foot is pushing that way. So therefore, what does the ground do to your foot? The ground pushes against your foot, so that would be the reaction, but what direction? Opposite, which would be that way. So which way do you walk? So even though your foot's going backwards, your body is going forwards because of this equal and opposite reaction thing. Take a look at that rocket there, for example. So that rocket is pushing gas molecules out the back end of the rocket in that direction. So what's the reaction force? It would be the gas molecules are pushing back against the rocket this way, and that's the reason why the rocket goes in that direction. So a interesting example of this would be, what do they do to astronauts in the International Space Station? Well, I like to think that they haze them. Okay, so the newbies, when they go up to the International Space Station, one of the things that they do is they put them in the middle of the space capsule or the space station, and they leave them there. And so if they're in the middle of the space station and they don't have anything to push against, then they're in real trouble because there's no reaction forces, so there's nothing that would cause them to want to move. So how do they actually move in outer space? So they have like an aerosol can, and by squeezing the aerosol can, molecules come out in this direction, but the molecules provide a reaction force that pushes them in the opposite direction. So if they were in the middle of their cabin, if they had an aerosol can, they would be able to move, or if they could somehow manufacture gas in one way or another, then they could also move. Now, you know that they've done this. It's not the kind of thing that they put on the NASA website, but I am sure that they have conducted these private experiments up there in the International Space Station. Okay, so that is Newton's third law of motion. Okay, now in our next segment, we're going to start talking about momentum.